Hi, I'm Chris and welcome back to the channel. In this, the third in a series of videos charting my journey into the world of Home Assistant, I'm going to be looking at how I went about selecting and then integrating some smart plugs into Home Assistant. We'll then create some simple dashboard controls before adding our smart plugs with power monitoring capabilities into an energy dashboard as the first step in monitoring our household energy consumption. If you're enjoying the video, please do give it a thumbs up and click that subscribe button to get alerted when new videos are released. And with that said, let's get started. When I was looking around for a suitable smart plug to integrate with Home Assistant, I had a few key requirements. Firstly, I wanted a device with power monitoring capabilities, as monitoring energy usage was as much the purpose as being able to turn things on and off remotely. Secondly, and it almost goes without saying, the device needed to be capable of integrating into Home Assistant in a reasonably straightforward manner. After all, I wasn't looking to reinvent the wheel. Thirdly, it needed to be a reasonable price, as the cost would soon mount up if I ultimately purchased quite a few. After a brief search, the Local Bytes power monitoring smart plug appeared to tick all the boxes, complemented by a good online knowledge base and blog. Being a relative newbie to all this Home Assistant home automation stuff, I hadn't really given too much thought as to how a smart device, such as a smart plug, actually worked. I presumed that it would run some sort of communications protocol to allow it to talk to a controlling application, whether that be Home Assistant or something else, but wasn't aware of much beyond that. It turns out that a lot of smart plugs are based on the ESP series of low-cost, low-power microcontrollers, which often come with integrated Wi-Fi and sometimes Bluetooth capabilities. Of course, a microcontroller is not much use without some form of firmware that supports the features we've come to expect in smart plugs, such as remote switching on and off, power monitoring, etc. etc. Perhaps the two most common firmware options for ESP devices are Tasmota and ESPHome. And whilst it's not the purpose of this video to dive too much into the detail of each of these, it is worth a quick review, as it has a direct effect on the way we go about integrating our smart plug into Home Assistant. So which firmware option does the Local Bytes Smart Plug use? Well, the clue's on the box: Tasmota. Tasmota is open source firmware for ESP devices and features total local control with quick setup and updates. It can control devices using MQTT, Web UI, HTTP or even serial protocols. It allows automation using timers, rules and scripts, and integrates with home automation solutions such as Home Assistant. So why have Local Bytes chosen to ship their smart plugs, and bulbs for that matter, with Tasmota by default? The reasons given are that devices can be controlled on their own via the Web UI, including via mobile apps, and can be connected to multiple different smart homes in a flexible manner. Tasmota is also feature-rich and very well documented. But of course, that doesn't mean that ESPHome doesn't have any advantages. With ESPHome, devices on the network can be automatically discoverable, and users can update the functionality of the devices by editing a YAML file within Home Assistant. Finally, and perhaps most relevant to this video, Home Assistant can communicate directly to ESPHome without the need of an MQTT broker. What all this means for how we integrate the Local Bytes Smart Plug into Home Assistant is that we need to use an MQTT broker, MQTT standing for Message Queuing Telemetry Transport, which is a bit of a mouthful. And then Home Assistant must publish commands to and subscribe for state changes from the MQTT broker. In a similar manner, the Tasmota device must subscribe for commands from and publish changes to the MQTT broker. Contrast this with the apparently simpler process whereby ESPHome uses a bidirectional API, Application Programming Interface, to talk directly to Home Assistant. Now, As was indicated in a previous slide, whilst it's possible to reflash the Local Bytes Smart Plug with ESPHome firmware and thus utilise the API for communication with Home Assistant, as the smart plug comes with Tasmota pre-installed by default, in this video we're just going to stick with that and thereby use MQTT. Now, if by this point you're thinking this all sounds incredibly complicated, fear not. The actual process of integrating our Local Bytes Smart Plugs is pretty straightforward. By following each of these steps in turn, we'll soon have them integrated into Home Assistant, whereupon we'll then create a simple dashboard to provide on-off control and monitor the power consumption of the devices to which they're connected. Now, if you're following along with the Local Bytes Getting Started blog, see the links shown earlier, also in the description below, you'll note that connecting your smart plug to Wi-Fi isn't the first step shown in the process. However, as I was keen to see something working, I jumped straight in and plugged in my smart plug and turned on the power. Then, after opening the Wi-Fi settings on my computer, I looked for a network that started with Tasmota, whereupon I joined it. At this point, my PC was connecting to a Wi-Fi network created by the smart plug. Unfortunately, I was that keen that I forgot to screen record this, but there's nothing special about joining a PC to a Wi-Fi network, so hopefully no great harm done. At that point, and with screen recording now enabled, the next step was to open a browser window and connect to address 192.168.4.1. After a short while, the web UI for Tasmota will be displayed and a list of Wi-Fi networks presented. Select the required network, then type in the password and click Save. At this point, Tasmota is trying to connect the smart plug to your selected network. Once it's been successful, the browser will automatically be redirected to the smart plug's IP address, in this case 192.168.1.192. During this process, the network connection will be interrupted, and you may find, like me, that the browser didn't connect successfully. In this case, a quick refresh of the page should bring up the Tasmota web UI. Selecting Configuration and then Configure Other allows us to give our smart plug a more user-friendly or unique device name than the original Tasmota default. It's at this point that, in retrospect, I think I made a bit of a boo-boo. As the couple of smart plugs I'd purchased weren't going to be dedicated to specific devices and were instead going to be moved around the house to allow me to monitor power consumption of various devices, I thought I'd be clever and give them generic device names. For example, Tasmota_LB_smart_plug_1. Wow. Why was this a mistake? Well, apart from them being a mouthful, when I later came to referring to these devices in Home Assistant, it seemed to me that I couldn't edit them in certain places, at least as far as I could find. So name them wisely. Once you've entered the device name and friendly name fields, click Save, and the smart plug will restart after a few seconds, again displaying the web UI. Okay then, whilst there's plenty more configuration options that we could explore, they're perhaps for another time. Instead, after plugging a desk lamp into the smart plug, I wanted to try out toggling the lamp on and off and seeing whether it worked. And of course it did, although confusingly Tasmota was reporting back a voltage of 324 volts and not something in the range of 220 to 240. The power consumption figures also looked a bit awry, so definitely something to look into later. Anyhow, at least I now had a couple of smart plugs connected to my Wi-Fi network and operable via the web UI. However, nobody in their right mind would go through this rigmarole just to use the Local Bytes Smart Plugs via the Tasmota web UI, would they? If you're just after a nice, easy-to-use smart plug with user-friendly mobile app, there's plenty of choice out there, such as TP-Link's Casa and Tapo devices, Meros, Eve, etc., etc. But the aim of this video is to integrate our smart plugs into Home Assistant, so that's what we'll do next. In this video, we're going to be using the Mosquitto add-on as the MQTT broker. There are other choices available, but as this is the one recommended by Local Bytes, it seems sensible to stick with it, at this stage anyway. Installing this is relatively straightforward. So, starting from our YouTube demos dashboard, we first navigate to Settings, then Add-ons, and then select Add-on Store at the bottom right of the screen. This causes all the available add-ons to be displayed, but we can simply search for the Mosquitto add-on by typing MO in the search bar and then selecting the displayed add-on. Clicking Install will then start the installation process. Note that this took around 2 minutes to complete on my Raspberry Pi 4, so a little bit of patience is required. The Start on Boot option is already selected, but it's also a good idea to also enable the Watchdog option to ensure that the broker doesn't unexpectedly go down. Clicking Start will set the broker running and cause the CPU and RAM usage information to be displayed as shown. And that's it. We've now installed and started the MQTT broker. Now that we've got the broker up and running, we need to add a set of credentials. We'll use these in a later step when we come to connect the smart plugs up to the broker. Starting from the settings screen, we navigate to People and then select Add Person at the bottom right of the screen. Enter a name for this person. We'll use Tasmota in this case, and then select Allow Person to log in. We then need to add a username and password. In my case, I used Handyman as the username and then entered a password. Do make sure you keep a note of these as you will need them later. Re-enter the password to confirm it, and then select Create to add the user, and then Create again to add the person. And there we have it. We've added a person called Tasmota. Whilst that's strictly all we need to do to configure the MQTT broker, we can optionally add a set of local user credentials to the Mosquitto configuration, which can be useful for testing purposes. So whilst we're down in the guts of things, let's do that now. Before we do, however, we need to enable advanced mode. Starting again from the settings screen, we select our user profile by clicking on our name bottom left, and then scrolling down the profile page to find the advanced mode option, which we enable, and then it's back to the settings screen. Okay, let's add that set of local user credentials we mentioned. Selecting add-ons and then the Mosquitto broker takes us into the Info tab. If we now select the Configuration tab, we see there are various options and settings that we can choose. In the Logins box, we can now add a username and corresponding password that can be saved in the broker configuration. Here I've just used a couple of generic examples, i.e. tas_user and tas_password. Ideally, these should be replaced with some more meaningful credentials of your choosing, but they'll do for now as we're not going to be using them in the remainder of this video. At this point, it's important to click Save, which the observant amongst you will notice that I've failed to do. But hey ho, you get the idea. Back to the Info tab and we're all done. Right, you'll be glad to know we're now finished setting up the MQTT broker, so we can move on to the final step of connecting Tasmota, running in the smart plugs, to MQTT. We're now ready to connect each of my two Tasmota smart plugs to the MQTT broker in turn. Navigating to smart plug 1 first, which in my case is at address 192.168.1.227, we first select Configuration, which unsurprisingly takes us to the configuration page, and then select the Configure Other option. At this point, it's recommended that we update the device name and friendly name 1 using the same name value for both. As I'd already done this step and saved, in my case I'd just return back to the configuration page. Selecting the Configure MQTT option, we then need to update several fields, starting with the host details. This needs the IP address of our MQTT instance, but as the version of Tasmota that's running in the smart plugs is greater than 12.1.1, it's as simple as just entering homeassistant.local. Next, we enter the name of the user we previously created in Home Assistant, which in my case was Handyman, and then the corresponding password. The value in the client field must be unique for the user, but the default value will work, so no need to change anything there. OK, clicking Save will save the updated configuration and then restart Tasmota in the smart plug, which just takes a few seconds. With a little bit of know-how and a lot of luck, and providing that Home Assistant is set to auto-discover, which should be on by default, our first smart plug should be discovered automatically. Let's find out if that's the case. So, back into Home Assistant, navigating first to Settings and then Devices and Services causes the list of active and discovered integrations to be displayed, of which the MQTT broker is one, awaiting configuration. Clicking on the Configure button results in us being prompted as to whether we want Home Assistant to connect to the Mosquitto MQTT broker, which obviously we do. So after clicking on Submit and a little bit of whirling, we are informed that the configuration for the Mosquitto broker has been successful. Once we've selected Finish, the display is updated to show that the MQTT broker is now a configured and active integration. But that's not all. We now have a freshly discovered Tasmota integration. So let's go ahead and configure that as well. After confirming that we want to set up Tasmota by selecting Submit, this quickly completes, and following us clicking Finish, we're prompted to specify an area for our new smart plug device to be associated with. Both my smart plugs will initially be used in the kitchen, so let's choose that and then select Finish. Now we can see that we have an active Tasmota integration with one device associated with it. Looks like we're getting close. Clicking on that device link then takes us to a full page of controls and information relating to Tasmota Smart Plug number 1. Now you can probably appreciate why my naming convention turns out to be a bit clunky in practice. Much better, if you know where your smart plug is going to be mainly used, to give it a meaningful name, such as washing machine or tumble dryer, etc. Anyway, at this stage, perhaps the most interesting item on the page is the simple control top center, which looks like it would allow us to turn the smart plug on and off. So let's go ahead and add it to a dashboard. For now, we'll just use the very simple card that Home Assistant has provided. Now that's completed, navigating to my YouTube demos dashboard results in us seeing the newly added smart plug card, whereupon we can use to turn the smart plug on and off to our heart's content. You'll just have to trust me that it was actually doing something, but I assure you it was. Well, it's certainly been a bit of a journey, but we have now finally managed to integrate our shiny new Local Bytes Tasmota smart plug into Home Assistant. Success! Unfortunately, we need to repeat all of that again for Smart Plug 2, but now we know what we're doing, it should go pretty quickly. But oh, I spoke too soon. Despite updating the MQTT configurations for Smart Plug 2, there still only appears to be one device shown on the Tasmota integration card. No matter where I look, it just doesn't seem to appear in the list of devices. Back to the MQTT configuration page, and the reason why immediately becomes clear. I omitted to update the host details to homeassistant.local. Once that's done and the device is restarted, our second smart plug miraculously appears in the device list. Going back to the integrations page, we now see that 2 devices are shown on the Tasmota integration card. Drilling down into those devices and clicking on Smart Plug 2 takes us to a full page of controls and information similar to that we saw earlier with Smart Plug 1. You'll note that no area has been specified for Smart Plug 2, another foul up on my part, but at least we can now toggle the control on and off, signifying that our second smart plug is fully integrated into Home Assistant. Let's now get the control onto our favourite dashboard. We'll stick with the same simple card that Home Assistant suggested for Smart Plug 1, and there we have it, both smart plug controls available on our YouTube demos dashboard. However, before we're finished with this step, we need to go back and define the area where Smart Plug 2 is located, as it's currently still undefined. Navigating to the device info page for Smart Plug 2 and then clicking on the pencil icon in the upper right corner allows us to either select an area from the existing list or add a new one. Of course, I was on a roll now and mistakenly selected Home rather than Kitchen as per Smart Plug 1. While this won't stop us from operating the smart plug correctly, it's better to have some consistency, especially if at a later time we start to group controls and dialogues by area. So round the loop again, doing it right this time, so we finally end up with both smart plug 1 and 2 being defined as in the kitchen. And that, as they say, is that. Both Local Bytes Tasmota smart plugs are now fully integrated into Home Assistant. As a newbie learning my way around Home Assistant as I go, I'd say the process is straightforward as long as you have something to follow. Trying to do this from scratch would be very problematic, at least for me. In this regard, the Getting Started with Tasmota webpage in the Local Bytes knowledge base was really invaluable. Before we have a look at elaborating our dashboard a bit, now seemed a good time to do a little bit of tidying up. As I was getting fed up of typing out my long convoluted generic device names, a little bit of simplification seemed in order. Going back to the Tasmota web UI, in this case for SmartPlug 2, and navigating to the Configure Other page, I updated both the device name and friendly name 1 fields with a shortened version of my generic naming convention. After clicking Save, the SmartPlug restarts after a few seconds, whereupon it's now just simply TLB_plug_2. Not sexy, but much better. What does this mean for Home Assistant? Will it throw a spanner in the works? Well, no, the change in device name has propagated through to Home Assistant automatically, as indicated by both controls now being identified as TLB_plug_1 and 2. However, we can see that the titles of the respective cards on the dashboard are unchanged from those original long-winded names. So let's update those now to something more meaningful. Clicking the 3 dots ellipsis at top right takes us into dashboard edit mode, whereupon we can edit each of the cards in turn. Starting with the card for plug 1, we update the title to Kettle, as this is where the smart plug is initially going to be used, and then click Save. Following a similar process for plug 2, we update that to Microwave. Selecting Done, we exit from edit mode, and now have a dashboard that, whilst it won't win any prizes for aesthetics, at least gives us simple control of our 2 newly deployed smart plugs. Am I particularly interested in the energy consumption of my kettle and microwave? Well, not really, not at this stage at least. However, they're probably the most regularly used devices during a normal day, so would likely build up some good test data relatively quickly. For a little light relief after all that hard integration work, I thought I'd see if I could create some better dashboard controls. And so, in homage to Blue Peter, here's one I made earlier. Starting at the top of the vertical stack, we have a large in-your-face on-off control, which changes colour to reflect its current state. The next is a very simplistic on-off control, similar to what we saw earlier. Obviously, this duplicates the functionality of the control above, but I thought I'd add it anyway. After that, we have a gauge indicating the current power being drawn by the device that's plugged into the smart plug, in this case a kettle, with units in kilowatts. Finally, we have some energy consumption figures expressed in kilowatt hours for yesterday, today, and the total since we started using the smart plug. So how did I go about creating this? First, we go into Dashboard Edit mode and select Add Card. Scrolling down, we find a control called Vertical Stack, which allows us to group multiple cards so they always appear in the same column. Selecting that, we're presented with a whole range of objects that we can add into the card, wherein we'll choose the large on-off button and give it a name, i.e. microwave. Clicking the plus sign, we now have the option to add another object into the stack. Home Assistant has auto-suggested some entities, but these aren't relevant, so we'll click on the first one and then scroll down the list to find the simple on-off control instead. We'll then delete the remaining 2 entities, and then change our mind and delete the microwave text that we entered earlier into the name field. Clicking the plus sign again, we'll scroll down and choose a gauge. Home Assistant again auto-suggests an entity, in this case relating to the Govee Smart Thermal Hygrometer that we integrated in an earlier video in this series. But we obviously don't want that, so we find one that relates to the instantaneous power being consumed. Note that the units are currently undefined, so we've defaulted to watts rather than kilowatts, as was displayed on the kettle version of this control. For now, I'll define the maximum value for the gauge as 1000 watts. Once more on the plus sign, and we can just add a few entities. Selecting the required items in turn, we can add in the energy consumption for yesterday, today, and in total. OK, after a quick review of each item in the stack, I obviously decided I didn't like the naming convention under the power gauge, so I added a friendly name before clicking on Save, wherein our newly created vertical stack of controls for the microwave is presented. A quick side-by-side comparison to check all is well, and then we can click Done and exit edit mode. One of the useful features within Home Assistant is the Energy Dashboard, which provides a home for all things energy related, including monitoring electricity and gas consumption, solar power generation and battery storage, amongst other things. Although it's possible to create your own custom energy dashboard, you only need to do a quick Google troll to find many visually impressive versions. For now, I'm going to stick with the Home Assistant version, given my limited development expertise, at least at the moment. With that in mind, I'm going to add some individual devices to the dashboard, namely the smart plug energy monitoring for the kettle and microwave. Now, as noted earlier, these are probably not the items of most interest in terms of energy consumption. You would probably consider higher power devices like the washing machine, tumble dryer, oven, etc. as more meaningful. However, for now, let's first delete a device that I'd already added and go through the process of adding in the smart plugs for the kettle and microwave. Note that in each case I've selected the total energy entity, as I'm interested in monitoring energy consumption over time. Selecting the back arrow at the top of the energy dashboard configuration page takes me back to the list of dashboards, whereupon I can open the energy dashboard. We now have a bar chart indication of the total energy consumed by both devices, the view of which can be customized to show anything from day, week, month and year. After a brief final sanity check, we can see that the total energy consumption figures reported on the energy dashboard are the same as those on the vertical stack controls. Clearly, there's much more we could do to enhance the functionality and appearance of our own dashboards and the inbuilt energy dashboard. But for now, we'll leave it there, as we've already covered a lot of ground in this video. If you've made it this far, thanks so much for watching. I hope you found it both interesting and informative. In future videos in this series, I'm hoping to further develop my energy dashboard, probably starting with linking in our electricity and gas consumption via the Octopus Energy Home Assistant integration. Please do consider subscribing if you think this might be of interest to you. If you like the video, please do give it a thumbs up, it really does help. And don't forget to comment, good or bad, I read them all. That's it then. Thanks again for watching and hope to see you on the next one. Cheers.